Welcome back to Linear Optimization. We're going to give an example of performing a pivot. Here we have an organized tableau, similar to before but slightly different. So it's not the same example that we did earlier. What we're going to do is we're going to look at the fact that we have the basis x2, x4, x6, but in the order x2, x6, x4. Remember, the order is important. And we're going to pivot to place x3 into the basis. So the first thing we need to do is to compute theta 0. So remember, it's the minimum of a set of ratios. Specifically, I will look at each row of this vector and compare this entry divided by this entry. So we have 5 divided by 1, 8 divided by negative 1, and 2 divided by 1. However, we also said that we needed these entries to have strictly positive value when we compared them. So this entry does not count. So I want to take the minimum of 5 and 2, so it is equal to 2. And moreover, this is the position where that ratio occurred with minimum. So this is the place we want to pivot. We want to pivot at this place, which means I want to replace x4 with x3 in the basis. Now, all we need to do to finish is to rediagonalize our tableau with respect to the new basis. That means that I want only a 1 in this position, and I want zeros in the others. So we need to perform row operations in order to clean up the tableau. However, they're pretty simple in this case, because I just need to take the third row and add it to row 2, subtract it from row 1, and add it to row 0. So these are the row operations we want to perform. Let's do them. So after performing row operations, we should have this new matrix, new tableau. And what is nice is that we've got our new basis marked out, and we've got it in the proper order with the replacements we have. And you can see I have a 1 here, and a 1 there. But also, when I look at this position here, we have the new basic feasible solution can be read off. It's that x2 is 3, x6 is 10, and x3 is 2. And our new cost function is actually 1. Remember, this position is the negative of the cost function. And what happened is that from here to here, the negative value increased, which means that our cost function decreased. The reason it decreased is our relative cost is negative. So it's beneficial to use this one, and that's why we have improved it. And so next we're going to talk about the simplex algorithm and why when we select these things, we can actually improve the solution until all of these things are non-negative.